Hello, everyone. Welcome back. Previously, we are talking about structural quality, in particular, structural metrics. We talked lectures ago about loops, the tangled metrics. Basically, searching for loops in the connection between classes or packages. All this is about classes or packages. Then in the previous lecture, finally, we cover abstractness and we cover instability. An important thing to remember for your exam, the metric is about instability, not about stability. So these numbers 0 to 1 represent the instability. Therefore, 0 is stable and 1 unstable. We talk about these two. And the most important thing, we talk about this 2D plot in which we can cross-reference them. We talk about the relationship among those two and whether or not these zones here are bad, painful, or useless. Both are bad. And how what we want to have is software, classes, and packages that one way or another are close to this line. And we stop there. Something that we need to review regarding this is the metric that is going to measure the distance to this line. And then we need to move to another metric. So with that, hopefully we can complete this topic of the metrics. And now that you submit your assignment, and now that you have a big class diagram, hopefully, we can use these metrics to evaluate the quality of the software that you submit in the last sprint. So, checking. Previous lecture, we work with this slide. We work with this calculation of stability and abstraction for these packages. If I ask you in your quiz, in your exam, about those packages, C, X, A, and we remember this picture, can you tell me which of those three is better than the others? Which of these three scenarios could be better quality or in my best position? In a different way to ask, in which of those three packages would you like to be working? The one that is using the others, the one that is in the middle, or the one that is being used by other? Can you imagine the position of those three in the plot, where they are? Use as an exercise, question number 1 that hopefully you have is like, well, what about abstraction? Scenario number 1, let's think about all the classes in those packages are concrete classes. Those packages do not have interfaces. Those packages do not have any abstract class. Use concrete classes, all of them. So if I tell you that, what I am telling you is for all of them, and that is one scenario. All of them concrete classes. Therefore, abstraction, abstractness, 0. All of them are going to be moving in the flat line with abstraction. Now, the other metric, which of those three is going to have instability equal to 0? Can we agree about A? How do we know that? Because of the equation, right? Because of the equation, easy. This one, A, do not have outputs. There are no lines going out. And therefore, this number here is going to be 0. And it doesn't matter what happened below. It doesn't matter that I have this one input. the reality is no output, that guy is going to be 0. It's going to be 0 because that one, no outputs, is not using others, but it's being used. 0, 0. That A is a problem. That A is here. Why is a problem? Because if you are working in A, there are other team or other team member, whatever, that is using your work. And if you do something wrong, there are going to be someone waiting for the correction. That is what the number is telling me. It's just be careful with that guy. What about the others? In particular, what about C? What is the instability of C? Can you calculate that one? C, instability equal to? Yes. Hopefully it's easy. One output. And there are no inputs, so 0 plus 1, 1. Instability 1. Instability 1, abstraction 0. That is my happy face. When I ask you in which one do you want to work, probably that C is the equivalent as I am going to do the main class. I am going to do the main class. Why? Because I am going to be using others, but no one is using the software that I am doing. So I can do mistakes, or I can be the last one to finish my work. And as far as I finish 1 minute before the submission, I am fine. I am using the others. The classical example is that C is the main calling methods in other classes or inheriting from other classes. Remember, the arrow, that one is just a connection between the packages, that one, dependency, but could be any other. We are not counting for categories. It's just the line going out from C. So the happy one, the one that do not cause problems. And again, I am talking about problems in terms of communication with the people, instead in terms of that one, how the connection is between this software and the others, and therefore the developers of this one with the others. Those are the things that we're discussing here, teams and communication in the structure of the software. We are not reviewing the complexity inside of the packages. That is going to be a different story with cyclomatic complexity and lines of code. Used for the connections. Instability for the one in the middle. Can you guess the value? Can you calculate the value? Yeah, easy, right? That one is going to be like here, right? Somehow is middle point. There is no value for this. There is no value, a magic number regarding in which point the pain zone finish. But usually 0.5 is outside of the pain zone. Is somehow okay. Well, I am using others. Some people is using me. The idea here is that theoretically, remember, these are numbers. Theoretically, the quality of that X is 50% responsibility of others, 50% this connection that I am using others. So 50% is what I am using from others, and 50% what I am doing. Again, there are no magic numbers, but just the idea is, well, if someone is using me and I am using someone else, hopefully it's 50-50. What I put in the code, what the other give me. So 50-50, the responsibility, 50-50, the numbers in the middle. Not 100% true, but again, it's just to give us an idea of the problems here. With A is everything is my responsibility. people is using me. I am not using anyone else. So I cannot put the responsibility in others. It's going to be whatever happened here, my fault. So 0 with abstraction and 1.50. What happened if I told you a different story? If I ask you a different question, you know what? All these 3 packages, all of them, the only thing that they have is abstract classes or interfaces, whatever. So for all of them, abstractness go to 1. All of them, without going into the details. Obviously, that is immediately kind of a bad idea. Everything is abstract, really, whatever. What happened with the numbers? Now you have one thing here, one thing here, and one thing here. And the only thing that I want you to notice is now the things are the opposite. Because before this 0, 1, my happy face for C. But if I told you that the only thing that I have here in C are abstract classes, and therefore you move here, now that one is bad. Why is bad? Because basically what we have is this package that is using others, like the idea with the main. But now I am telling you that the class or whatever is inside do not have the main, because the main cannot be in an abstract class or in an interface. I am telling you that I have an interface, and that interface is using others. And obviously you know that an interface is not for using other things, but an interface is to be used. So if no one is connected with C, and the abstractness of C is 1, that is just coding that you did and is not doing anything. Well, that is a very good question, and very common. What I want you to remember, the way of the things are used here is stable, unstable, or unstable. The word stable means hard to change. Yeah, I mean, it's stable and that means it's hard to change. It's unstable and that means that it can change. That was the definition that the guy that created the metric put there. And yes, for some people it's like, so unstable is good and stable is bad. Usually in physics, we could think about the opposite, right? Something that is stable is good, something that is unstable is bad. It's like, please state. Here, a good point to remember is switch your concept about good and bad. Yeah, it could be a good idea. The only thing is, remember, in the books, you are going to find the letter I. So just remember the meaning for the metric. What you're going to have, these numbers, even though I am telling you how to calculate the numbers with the equation, really, what you're going to have is a software that calculates these numbers for you. So the only thing that you're going to do in order to get numbers, you do not need the diagram. I am going to ask you for the diagram and we're going to play with the diagram, but really, you can pass your source code to a tool that we're going to review, and the tool is going to give you a report. The report, obviously, is going to include metrics such as cyclomatic complexity, line of code, and so on, but also this A and E, I, and so on. So I need you to remember the meaning of that letter. And yes, you can connect the letter with modificable or not. It's a metric of modificability. That is correct. Use, as you mentioned before, someone mentioned in the chat, switch the meanings. What is good is unstable. 1 is a good number. Well, you need to verify abstractness also, but yeah, usually a high number is okay for a normal class, for a class that is not abstract. So stable, unstable, stable, hard to change, and only incoming things. Unstable can change, and can change because, well, mostly you have ongoing lines. So my answer for the question, and something for you to remember. Pain zone, useless zone, the good part, the line that connects 0, 1, 1, 0. Closest to the line, the better. That is the combination that you will be looking forward. So with this principle, this is stability, stable, abstraction principle. The principle that makes stability with abstraction. Always, always, always. More stable. Remember, more stable mean values that are low. I equal 1, unstable. I equal 0, stable. So lower values for the metric I, that means that you need a high value for the abstraction, for the abstractness. So principle number 1, stability and abstraction, they should be the opposite. Why? Because we want to be in this line. If you have a 1 here, stability should be 0. If you have a 0, stability should be 1. Opposites. Clear. So, thing number 1, you have a diagram, packages, classes, calculate one, calculate the other, and the first comparison that you are going to make is whether or not they are opposite, whether or not they are going in different direction. Therefore, whether or not, if you can imagine this 2D space, whether or not they are close to this line, and therefore far from being equal. If you notice, the zones that are bad are those in which the values are the same, 0, 0, or 1, 1. For one reason or another, painful, useless, whatever. But if they are the same value, we have something that is not good. Stable abstraction principle, SAP. In one line, that is the definition, the explanation, the picture, the 2D scenario, and now you know how to calculate the numbers. In the examples that I provide, which one? This one, the packages. The packages, two things that we need to review. Scenario number 1, when I told you that abstraction is 0, 0 for all of them, and you calculate instability, and when you calculate instability, you agree with me like, well, this one 1, this was 0.5, and this was 0. When I told you that the scenario is that the packages do not have abstract classes, that the packages only have concrete classes, which of the 3 packages is the best option, is good to go? No one cared about it. Someone that we mentioned is, you can notice these 2 are the opposite, and they are the opposite, they are here. This package C is a happy face. That package C is like, yeah, I would like to work with C. Why? Because I can change whatever I want and no one is going to suffer. If I make mistakes, nothing happens. Usually that happy face is the place in which you want to put maybe the new programmer, because there is no possibility almost to cause problems there. And again, the example that I can give you, the main is there. your main class, all these classes that we have created with the main, is probably that one. No one is using that class, but that class is using others. Probably the numbers are going to be like that, 0, 1, or close to that. That is a happy one. In this scenario, the one that is worried, the one that can have problems, the one that you need to take care of, the one that need a nanny, is the last one. According with the principle, these are the same. If they are the same, you can map this in the 2D scenario. We are talking about being here, painful zone. Why the painfulness? This guy, someone is using it. So I am working in something, and there are people in other team or in my team using what I am doing. They depend on me, and that means I can be a risk for problems. You do not want this to be the new programmer. You don't want this to be someone that you cannot trust because there are people waiting for results here. So this one is the worry one. Again, thinking about no abstract classes. Yeah, abstraction 0.5, yes. Remember that we mentioned this. In one class, it's only 1 or 0. For one class, one file, the class is abstract, yes or no. So it's 1 or 0. But when you have a package, remember, we reviewed this example in which you have 3 classes in a package, 3 files, and one of them is an interface, or one of them is an abstract class, and the other 2 are concrete classes. So in that scenario, your abstractness for the package is going to be 0.33. So 1 abstract in a total of 3. And we reviewed this idea of how to calculate the number. And basically, it's how many do you have abstract divided by the total. So yeah, the abstractness for the package could be some number between 0 and 1, including 0.5. Good. So this is the scenario, the happy one, and the one probably instead of sad is kind of the one that you can be kind of worried, like be careful with the team or the people that is working there because they could be the responsible for everyone else to fail. The opposite is if I told you that abstractness is 1, if I put all the content abstract here, the situation is going to be complete opposite. This one is the one that is going to be the worry one. The worry because it's going to be like, if I have a package and everything is abstract and no one is using that, whoever is doing this is wasting the time. And the opposite here, this is going to be happy because, yeah, a lot of people is using me, but I am an abstract class. The problem is not mine. The problem is going to be the people that implement me. So remember, an abstract class, it doesn't matter that someone else uses it. The abstract class do not have implementation, and therefore errors. Yeah. So here is this point. That is okay. That is kind of the point in which the situation is good. That is different. If you consider the lines that go in the opposite direction, this is bad, this is bad, this is bad, this is bad, bad, bad. But here, it's good. So yeah, 0.5, 0.5, you are in a distance 0 with the line in which you want to be. Yeah. That is the reason because it's important to notice the 2D scenario, the plot. But in general, talking about the principle is talking more about 2 1s, 2 0s. Good. So this is clear. Again, happy, worry. Worry, something is wrong, complex scenario, or wasting your time. No magic numbers. Use red lights. Use things that you, as a manager, as an engineer, whatever, things that you want to review, period. The numbers are just telling you when, where to review something. And probably the situation is good. Probably there is nothing that you can do there. Nothing that you can change here, but maybe you can change something. I am going to review examples. So SAP, done. According with the SAP, do you remember this scenario? Can you help me? A and B. Any of them have a problem? Should I be worried about any of this? And if so, should I be worried about A or should I be worried about B? I am going to assume that both X only concrete classes, Y also only concrete classes. Should I be worried about X or should I be worried about Y? Agree? To be sure, instability for X. Everybody agree, right? There are no outputs, so 0 divided by something. Instability for Y. The opposite. Are we clear, right? What I am doing, dividing the output, the input, the total, and so on. Which of those two is a problem? If I ask you without the numbers, it's like inheritance versus dependency. But when we have the numbers, and moreover, when we know that whatever content the packages have is not abstract classes, can you agree with me that this one, 0 and 1, looks like my happy face, and probably this is going to be like, I need to be worried about it? And notice that I am going to be worried about this one just because I am telling you that the package do not have abstract classes. So I am telling you, or you are going to notice that whatever inheritance is happening there is inheritance from a class, not from an interface. And basically it's like, if you are doing the class in the package X, and I am going to be inheriting from that class, you can be the responsible that my part failed. That is the reason of the numbers with the worry face. It's like, whatever is happening there, you need to be very careful that it's going to work well. Someone is using it. Okay, the scenario. This one needs to be more careful than this one. This one can go ahead. Do you remember this scenario? It's a question that I asked you before we start reviewing metrics. And again, I have this X and the Y. We reviewed them before, separate. My X and my Y. In the second example, I have this AC, a new one. And let me tell you, this X, the abstraction is 0. For this Y, the abstractness is 0. For this X, they are the same, 0 and 0. And for this one, AC, you know what? It's a new package, it's a new class, whatever. I'm going to put there abstraction 1. I put this new package, and that new package is going to have abstract classes, interfaces, in fact. If I give you these values for abstraction, basically I am telling you that everything is concrete except this new package AC. My question is again the same question that I asked you before. Which of these two solutions, A and B, is better, assuming that they are solving the same problem, the same solver? Yeah. Do you remember I asked you this question before? And before we agreed that B was better. Use looks better. We use like it the most because if you know object-oriented programming, we can agree that, well, it's better to have this abstract class and use the abstract class and then use polymorphic behavior to extend the abstract class and have childs. Just because of your knowledge of programming, you can argue that the B is better. But even without that, and without going into the details of the argument about whether or not interfaces are good or why they are good and polymorphic and so on, numbers with the SAP principle. And with the numbers, you can agree that, well, scenario number one, help me. What is the instability for X? Help me. What is the instability for Y? Can you help me with the numbers? What do we do to calculate those numbers? Yeah. The first one, we have these 3 inputs, 1 output. So 1 divided by 3 plus 1. And in the second one, well, we have these 3 output, 1 input, 3 divided by 3 plus 1. In the other option, well, instability of X looks like the same that previously or not? Something changed? It's going to be like 3 input, 1 output. Looks like the previous one. Instability for the Y. And obviously I need to calculate the instability for AC. Instability for the Y. I have these 4 outputs and no inputs, really? No inputs, remember? The direction, the inheritance is out. So yeah, 1, 1. What about the instability for AC? 2 inputs, no outputs, 0. Which of these 2 solutions is better according with the numbers? Well, according with the numbers, if you work in this 2D scenario, and if you work this one in this 2D scenario, what you need to do for the system, for the solution, is to locate the position of each of your packages or each of your classes, depending on what you are doing. For this example, I need to do this for everything. I am going to work only with the ones that we're reviewing. We don't care about these ones yet. We should put them in a full analysis. But well, here, what I can do is, you know what? I have both in abstraction 0, but one of them is 0.5 and the other is 0.75. Again, there are not magic numbers, but you can imagine that this guy here is very, very close or maybe inside of a zone in which we do not want to be. It's just very, very far from the ideal line in which we want to be. And this one here is kind of close. This one here is kind of okay. But this one is a problem or could be a problem. So solution A, I have something that is okay, and I have something that could be a problem. So it's a 50-50 solution, one good, one bad. The second solution, assuming that it's the same system, in the second solution, what I have is something that is one here, just like before, but I have one here, great, and I have another one here. So 2 perfect scores looks like, and 1 worry. 2 perfects, 1 worry. In the other, 1 bad, 1 worry, and the other almost perfect, whatever. If you take the numbers and you just do the math, it's like you are in the school and you have 2 A+ and 1 B. In the other, you have the same B, but you do not have 1 A+. In the other, you have 2 A+. You can figure out what is going to be your GPA. 2 A+, 1 B, 1 B, and the other A- maybe. If I ask you which one do you prefer, if I ask you in which one you are in a better situation, just because the number, the second one. But also, if this is the same software, always split in 3 people working, 3 different paths for tasks versus 2. I have better numbers and I have more packages or more divisions. With better numbers, we can go for that one. Again, the assumption is that it's a big software. The assumption is that we need to split things. If you do this for the house of the dog, for this small programming project in one of your computer science 101, this is garbage. For a big system, we want to split. It's a good idea to split. And I have 3 and with very good numbers versus 2 with limited quality in the numbers. The second one won't compare with the first one just because of that. And obviously, in both scenarios, it's going to be like, well, you can always do something to improve the one now. Make sense? So SAP, what you do, the numbers per class, the number per package, and then you compare. The numbers are going to tell you which opportunities you have to improve. That's it. Next, the other principle. We talk about SAP. Now let's talk about SDP. Well, in the first one, if you want to calculate like the numbers for this one, you have 2 numbers, 0.25, 0.75, and you can calculate the average only for 2 values. For the other, you have the 3 values. I mean, here you do not include AC. AC do not exist here. You do not consider AC at all. Use 2 values. We are just talking about this part. The comparison is similar because, as you can notice, the part that we're ignoring here are the same parts that we're ignoring in the second solution. So we assume that in both the scenarios, these things here and these things here are going to stay in the same way. And the only thing that we're analyzing is the center. In one solution is the center with 2. In the other is the same center, the same part, but now with 3. So the average there versus an average here, you can do the math, and that is more or less the point. Good. Okay. SAP, SDP. SDP, this is going to be somehow connected with the previous one, and it uses the following. Imagine that you have a package or a class, whatever, and you have another one. 2 classes or 2 packages. Very, very important. You compare classes with classes, packages with packages. So if one of these is a package and this one is a class, you are going to compare the connection between this class and one specific class inside of the package. You cannot compare one class with a full package. Hopefully that makes sense. So if you're calculating the abstraction of the instability for one class, you need to compare with the abstraction on instability another class, even though that class is inside of a package. If you want to compare the instability and abstraction of the package, then you need to use also the package in which the other class is. So apples with apples, bananas with bananas, always use the same. Do not mix them for the numbers. And the principle, the SDP, is going to tell you the following. You know what? If you are going to connect two things, doesn't matter what they are, every single connection should terminate. If you are using arrows, this terminate is the place in which the arrow is pointing. We don't care if it's inheritance, we don't care if it's whatever, but the place to which the arrow is pointing, that is the terminal. And if you calculate instability for this one, and instability for this one, you have the numbers for the two packages. Always, always, always. A good connection is going to be a connection in which the one in which you finish, the instability is lower. Really? We're going to show examples. The previous principle was all about the nodes, the numbers of the classes, the numbers of the packages. This one is about the connections. Good connection, bad connections. Good connection. A good connection happens between one package or one class with another one in which the second one, the one receiving the connection, have a lowest value in the instability. And use like the opposite, if you want to compare abstractness instead of instability, the rule is similar, but the rule is the second one, the one in the connection finish, that one should have a greater value of abstractness. Really? Yeah, think about it. I have this class, and I have this one, and action listener and the class that have my method main. Therefore, is a concrete class. Connection, the connection is realization. According with these numbers, that one is a good connection. What do you want to use? You want to use abstraction or you want to use stability? Abstraction. Abstraction of an interface, 1. Abstraction of a class, 0. The line ends. The line is pointing to the interface. That is good. In fact, that is the reason because the interfaces exist, because we want to inherit from them. What the principle is telling you with numbers is something that you already know as a developer. When you are going to use something, it's a good idea to use the parent. And it's a good idea to have the parent as an interface. And in terms of numbers, that is a good idea because the abstraction of the parent as an interface is going to be 1. So you are connecting one thing with abstractness 0 with another thing with abstractness 1. That is good. Okay, you know what? Everything is classes. I have this class and I have this class, and both are classes, both are concrete, both have abstractness 0. So if both have abstractness 0, when I connect them, doesn't matter the direction, I cannot really say anything about this. They are equal. So yeah, the recommendation is that I connect with one that have higher value. That is not true, but obviously, again, the numbers are evaluating the quality. It's not like you never use inheritance from classes, right? So 0, 0, I cannot use this one. It's not going to give me any information. But I can try to use the other one. I can try to use the other one, and let's think about it. I am going to be using this class. And you know what? This class is using another one, and this class is using another one, and this class is using another one. Using, you can think about inheritance or diamonds, a lot of diamonds here, whatever, using. And this class here, the opposite. Probably this is the main, and the main is going to use that class. And for some reason, maybe you have a workspace, and maybe that workspace is going to use that class. And you have a class diagram like this. And my question for you is, this connection here, would you recommend to have this connection? Yes or no? And you are telling me no. And if I ask you why, and we only trust in the diagram and in our knowledge of UML, well, it could be a good discussion here. But if we put over the table numbers and we understand these numbers, it's like, well, let's see. The problem here is the instability of this X and the instability of this Y. We need to calculate the instability of those two because those two are the source and the destiny of the connection. And basically, quickly, is the instability for X is going to be equal to, yeah. And the instability for Y the second one is greater. So the second one is greater, and according with the recommendation, again, no magic numbers, but the recommendation is the second one should be smaller. This connection is a very bad idea, according with the numbers. Can you explain me why it's a bad idea, according with your knowledge of programming? What is going to happen when we connect these two? What is the meaning of this one? Instability 0.33. Instability 0.33 is basically this guy there is not exactly a happy place. And the other, this one, is a great place. Think about the programmers that are working here. You have one guy, the one that is working with Y, and that guy is basically doing whatever he wants, using other things, happy. The guy that is doing X is already worried because anything that goes wrong here is going to impact other two guys. One happy, one unhappy. And you are going to link those two. The recommendation is no. Notice that the recommendation is you can do the opposite. You can connect the one that is happy with more things, because the one that is happy when it's going to use other things, the one that is happy when you point to other things, that guy is going to continue happy because using others do not compromise my results. The opposite, this one that is already worried because others using the one that is happy. If you can avoid that connection, if you can avoid that kind of problems, the communication between these two elements could be better. These are principles. These are recommendations. These are not magic numbers. These are not like, oh, according with the numbers, this cannot happen. These are just red lights. These are you things that, hey, this connection could be a bad idea. Can you figure out a different way to do this? And if your answer is yes, do it in a different way. If the answer is no, well, just be aware that this could be an issue. Going back here, there is a connection here. Here, there is a connection here, and there is a connection here. Those connections in green are the ones that I can evaluate according with the principle. The other connections I cannot evaluate because I do not have the numbers for this. So only the ones in green. Tell me, for the solution in A, here, the line in green, good or bad? Happy face or not for this arrow here? Remember, it's going from X to Y. It's moving from 0.25 to 75. Just for the note, remember, we have this one, a worry face, we have the connection with a sad face, and we have here a happy face. So now we have three elements, two because of the packages, one because of the line, and our combination is worry, worry, happy. So two worries, one happy. In the other scenario, what we already have is this idea of happy, and we still have the worry one. We already select the second one because the two happy versus one worry, the average. What about the lines? The connection between X and AC. The connection between X and AC, happy or not? Let's use abstraction. With abstraction, 0 to 1. With instability, 0.5 to 0. Pretty happy, right? Any of the numbers that you use, pretty happy. In the previous one, I didn't use abstraction because basically I have 0, 0. Nothing is going to result. The only thing that I can use is instability. In the second one, just because I have different values of abstraction, I can compare that one also, and it's a happy or totally happy. Both numbers are fine. What about the connection between Y and AC? It's in the opposite direction. Abstraction 0 to 1 and instability 1 to 0. In fact, if you notice, is the perfect scenario is a class inheriting from an interface. It's the best thing that you can do in object-oriented, right? And obviously it's a happy face. So now for the second scenario, what we have is happy, happy, 4 happies versus 1 worry. My numbers here use skyrocket. That is the best solution. SAP and SDP. And this basically is the explanation with numbers about something that you already know. When you have a class that is using another, it's better to transform this one in an abstract class and a child. Moving this one to these two is object-oriented principles. It's what you did with the design patterns. If you review the design patterns, most of them, the first thing that they do is to declare the abstract thing, the abstract factor, if you want to remember that one. It's a principle. The numbers obviously are going to show that applying that principle is a good thing. Good. So SDP, as simple as this. Any question, guys? Good. So this problem solved. You can expect similar to this, not the same one, but similar in your quiz or your exam. And the question as right now, which one is better? And even though the question is used, which one is better, 1 or 2, the idea is that you answer the question following what we did before, numbers. Numbers in the packages, numbers in the connection. So you can expect to have 3 minutes, 4 minutes, 5 minutes or something. And yes, you can use paper. So probably it will be a good idea for your final exam to have paper because you are going to be calculating these numbers. So question like this, another kind of question similar to that one. I am going to give you the other question, but before that, I need to review one more metric. And this is tricky. One more metric that we need to include to the tool set is this one, D. D for distance. Distance of your class of your package to this main line. In order to calculate the distance, if you want an equation, A plus instability minus 1, that give you the distance. Now, the distance is going to give you, as a result, a number between -1 and 1. Obviously, you can be here or you can be here. The distance is 1, but positive or negative. Positive or negative, and therefore the sign is going to tell you, well, you are far from the line, but you are far close to the useless zone, or you are far but in the direction of the painful zone. The distance metric is going to tell you that with these values, -1 or 1. Another metric, a different one, is this one. Do we notice the difference? We have distance and we have absolute distance. Distance, D. Absolute distance, the D inside of the bars. The bars, absolute value. The value for the absolute distance is going to be 0 to 1. So this one or this one, they are just going to be 1. Absolute value. We don't care about the sign. Two different metrics. In your exam, common error. I am going to ask you, maybe some of you, to calculate distance. Others are going to have the same question or a similar question, but asking for absolute distance. They are not the same. Be careful. Distance with the bars or without the bars. With the bars, the value is 0 to 1. We only care about how far we are from the line. Without the bars, we care about the sign. And therefore, we care not only about the distance, but also about the direction. If we are close to this place or to the other place. So, distance. The equation is the same, but with absolute value or without absolute value. Question in your exam, I am going to ask for one of these, the correct answer, as usual, one and only one. Be careful to read which one you are being asked for. With the absolute value, without the absolute value. You need the negative symbol or not. Good? And is how far you are from the main sequence, with or without direction. The only reason, again, my goal is that when you read the report that the software is going to tell you, you understand what is the difference between them. The only reason because we want one or the other in particular, the only reason because we keep this one is if we are curious about the direction. There is a problem there when we have values that are far from 0. We know that, and we can know that with both metrics. But when we have the sign, we know what is the problem. The problem is because pain, or the problem is because it's useless. That is the only thing that the sign is going to add to the value. Greater than 0, an issue. The sign, which kind of issue. Both metrics are going to be provided by the software that we are going to review. And the only thing is I want to be sure that you understand the difference between one and the other. So that's it. With your knowledge of math from high school, I think you can identify the difference between D and the bars with the D inside, right? I mean, this is nothing about software engineering. This is just, please remember the meaning of the symbols. Absolute value versus the full value. If you are asked for D, or if you are asked for D between bars, well, the question is going to be the same. The only thing is, we need the symbol, the sign or not. Just remember that. Good. Okay, distance. Your project. You can imagine that something that you can do in your project is put your classes or your packages in a diagram, something like this. I am showing you this project from another class, and what we have is one package here, one package here, there is a package here, another one here, another one here, and this one here. If I show you this diagram, again, it's something that the tool is going to give you, but now hopefully you understand the meaning here. Notice that for the tool, notice that in this scenario, instability is here and abstractness is here. For some reason, this tool in particular, invert the axis. So you'll be aware of that. But in any case, what do you think about this project? What do you think about the quality of the project? Is a project that we can modify and extend? Is a project that maybe is reaching a point of conflicts, problems, crash? So happy face or sad face for the project. And I am talking about for this collection of packages. But the idea is all these packages together solve a particular problem. What do you think about something like this? think about distance. Basically, the first thing that you do is to check for this part and this part. And as you mentioned, it's like, well, there is a problem here, obviously, but most of the things, and I am trying to represent with the circles the size of the package. So there are 3 packages that are kind of the most important, the biggest one. And yeah, even though one of the big one is here, 2 big are almost in the line. And there are a couple of small ones around. So far, I could agree with you. It's like it's moving forward. This one could be a problem. The recommendation for the team, the introspection, when you close your sprint, is like, well, maybe something we need to do here in the future. It's an area of opportunity, but so far we're moving forward. Yeah. Very, very good point. Remember, the numbers are telling us nothing magic. Is this one here is could be a problem. Could be a problem, but then you need to ask, is really a problem? I mean, there is a good reason because that package, the model, as you identify, is there. And well, I think that we mentioned this before, or maybe I mentioned this in a different class, but is the model. What happened with the model? That guy have all the functionality. Hopefully, all these are models, but if not, well, that is the guy that have the functionality. That is the guy that is being called by the controller. So there is a very good reason because that model is going to be in the pain zone. Even though, what if we split that model, that package into 2 or 3? Maybe if we split this, we can achieve to put the individual packages closest to the main line instead of having this big one in that part. Again, it's just what can I do to improve? Modify your model. How? Usually always the solution is split or change the connection, right? For this particular one, changing the connection could be hard. We already could have a model view controller if this is true, but split could be my second option. So far, good. You can improve and it's telling you where. The dependency, I'm not sure about the question. The dependency, okay, which one? In general, yes, dependency is good. Not sure exactly where here, but it's good dependency, low coupling. What if I told you that I did the same diagram, not for one project, but for different projects, like I can do with yours? And I just put big circles, again, in the packages that have more lines of code. So the size of the circles represent the packages with more coding, with more classes, bigger packages. And well, there are a lot of points that you can notice there, small ones, small packages. There are more packages than the one that I am showing with the red dots, but just to highlight things. This is just like the project that you submit. All of these are different projects, all of them solving the same problem, just like you did with the homework that I asked you to do. And when I put the source code of the teams in this particular tool that do automatically what we use review, calculate abstraction, stability, and use plot here, you can notice that the solutions have kind of different qualities. Question for you. Can you tell me which one of these solutions is the happiest? Can you tell me which one of these solutions is probably the sad? I am asking you to kind of grade or classify or select the good one or the bad one, just by looking to the plot that represent the solution. It is possible to do that. And if we understand what we reviewed today, probably what you are going to do is to check for the distance. Probably what you are going to do is to check for the pain zone. Pain zone, pain. And as you can notice, no one have useless. And the reason because no one has useless, and probably the same with your solution, usually students do not use interfaces. For some reason, when we are students, we go directly to the concrete classes. So that is the case here. So I am not reviewing for useless. I am just reviewing for painless zone. And as someone pointed out in the chat, two things, answering the question in the chat, two things that you want to review. Number one is the distance, yes. So if we consider the distance, we can agree that the average of the distance, that is going to tell us the best solution. But the other thing that we are looking for, more important than the distance, the pain zone. And someone in the chat told me that first solution looks like could be the winner. And yes, one reason. I haven't calculated the distances, but the reason because I can point out that one to be the winner, one thing, all these are solving the same problem. And that first one do not have software, do not have packages in the pain zone. And that is an achievement. So if we want to compare the others, you can notice 1, 1, 1, 1, 1, 1, 1. Everyone is kind of with one package in the pain zone. That could be the model, as I showed you before. But if I need to select one for this category, hopefully you agree with me, probably it's going to be that one because it's almost 3 packages in the pain zone. I am using the size of the circle to represent how many elements, lines of code or methods or whatever are inside. So what I am sharing with you without giving you the source code is the size of this and so on is almost the same size of these individuals. So we have 3 times really elements, methods, classes, or whatever, 3 times inside. It's not just like you split one in 3 small parts. It's really 300 lines of code there versus 100 lines of code there. So that one, the 4th one, the last one in the first line, there is something there, but there are areas of opportunities for improvement. So without calculating distance, I can select these 2 like no pain, a lot of pain. For the others, now I can just go and review this. And now I can start using distance. And as you mentioned, we can start calculating the distance and we can classify the others according with the average of the distance or somehow like that. Makes sense, guys? Good. So please review this. Loops, SAP, SDP, and be sure to be able to calculate the metrics, to apply the metrics, and to answer questions like the one that I have been asking you today. Next week, I want to make a quiz, and the quiz, something like this. So no homework to submit, just please review this material, practice. Yes, I need to upload the video, this one and the previous one. So please, as soon as you can, when the videos are available or with your notes, review this. Next week, we have a quiz. Questions? I am going to talk about the tool next lecture, and I am going to ask you to use the tool for a homework. Don't worry. Yeah, the quiz, my goal is to have a quiz during the class. just to be sure that you know this. And we're going to talk about the quiz. Don't worry. Good? Okay, see you next week, guys. Thank you.